All right. Hello again. We meet again. Okay, so we are going to be graphing the reciprocals, cosecant, secant in this first video, and then part two will be cotangent. Okay, so for cosecant is the reciprocal of cosine. So for us to graph it, what did I just say? No, cosecant is the reciprocal of sine. So for us to graph, we are going to go back to sine, and we're going to sketch. Let me label real quick. We're going to sketch the sine graph. So we know it goes up to 1 down to -1, and then we have this as pi and 2 pi, and then we went left 1 and so forth. Okay, so what I'm going to do is, since cosecant is the reciprocal of sine, is I'm going to plot the points 0, 0, pi over 2, 1, and so forth for sine. And the reason we're going to do this is so we have a baseline of certain things, and you'll see in a second. As I am sketching, it's dash because this is not the function that we're graphing, okay? We are graphing cosecant, not sine, so don't do it as a solid curve, as a solid line curve. Please, 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 please. Okay, it's just a basis for us. It's a guideline. So then the points for cosecant, remember, it is the reciprocal of sine. We're still going to go 0, pi over 2, pi, 3 pi over 2, and 2 pi for our x's. But if we look back at sine, the coordinate is 0, 0. Okay, so for y, it's technically 0 over 1. What's the reciprocal of that? 1 over 0. But we know that we can't, we cannot have a 0 in the denominator, so this becomes an asymptote. Why? Because it's 1 over 0. Pi over 2, 1. The reciprocal of 1 is 1. Pi 0. Remember, I'm just going back to these guys. Pi 0. Again, we have an asymptote. -1 reciprocal is -1 and so forth. So we can say that wherever the sine function intersects the midline, we're going to have an asymptote. Why? Because these are our zeros. And if you take the reciprocal of 0 over 1, you get 1 over 0, which is undefined. Okay, this is all we're going to find. We are going to find where the asymptotes are located and the maxes and the mins. For us, it's at 1 and -1. These are the only points that we need to find for cosecant. I'm not going to ask you to find anything else. And the reason is because from these maxes, we extend up. From the mins, we extend down. Now, what's nice is we have these vertical asymptotes, so we know that we're going to get really close, but we're never going to cross. It helps us to create the rest of the behavior of our function. Pretty nice, right? Okay, the period of the reciprocals is the same. Okay, so sine is 2 pi, cosecant is 2 pi. And the amplitude for cosecant doesn't exist, because don't forget, for amplitude, it's half the distance between the max and the minimum, or we can say that it's the distance from the midline to the maximum. Well, cosecant extends off to positive infinity and down to negative infinity. There isn't a max or a min. Okay, for the domain, similar to tangent, because we do have asymptotes. So we're going to say that it's negative infinity to positive infinity, except x cannot equal. Now, for tangent, it was the first asymptote, right? Or just an asymptote. I chose pi over 2, plus the period, because it occurred every period. For cosecant, it's, notice, the period goes from 0 to 2 pi. Within that, I have 2 asymptotes. So we're going to say pi plus half the period k. If you need to, write that down. It's going to be half the period, always, where k is any integer. Now, since we do have an asymptote at the y-axis for this parent function, you can just put pi k if you would like, or you can do the location of the asymptote plus half the period. Okay, our range goes from negative infinity to -1, inclusive, union, inclusive 1 to positive infinity. Okay, so there's cosecant. Let's go ahead and graph cosecant with a transformation. So that's page 8 of your notes. Okay, remember we need to always factor out the b value, but here we don't have one. We have a as -2. So that means we're going to have a vertical reflection because there's a negative in front of the a value. We're going to have a vertical stretch. We're going to go pi over 2 units to the right. Sorry, my writing looks awful. And we're going to go 1 unit up. Okay, so what we're going to do is we're going to graph. You can absolutely memorize these different points for cosecant, but like I said, I'm going to sketch sine, and I'm going to do it with the parent function. So I go 0, pi over 2, pi, 3 pi over 2, and then 2 pi. At 0, sine is 0, 1, 0, -1, and 0. Okay, again, we're sketching the sine function. Wherever it intersects the midline is where our asymptotes occur. Okay, so that means I'm going to have x plus pi over 2, and then -2y plus 1. If I plug 0 in for x, we get pi over 2. If you plug in pi over 2, you get pi. If you get pi, if you plug in pi, that becomes 2 pi over 2, and you add that to pi over 2, you get 3 pi over 2. 3 pi over 2 plus pi over 2 is 4 pi over 2, or 2 pi. 2 pi becomes 4 pi over 2 plus pi over 2, which is 5 pi over 2. Okay, if we plug in 0, we get 1. If we plug in 1, we get -1, and so forth. Fill that out with me, please. Okay, the period is affected by the b value. That doesn't change. Okay, so this is going to be 2 pi over b, which is just 2 pi. Amplitude does not exist. Okay, the amplitude does not exist because it's cosecant, not sine. We are using sine to help us graph it. All right, so I'm going to go 4 tick marks out to my period. Half of 2 pi is pi. Okay, and it looks like our max is 3, and our minimum value that we hit is going to be -1. You can go into the negative x-axis if you want. Okay, you don't have to. Knowing that, if I shift up 1 unit, that means that our midline is no longer on the x-axis. It is now up at y equals 1. At pi over 2, we are at 1. At pi, we're at -1. And then we go back up to the midline, we go up to 3, and it oscillates back and forth. Remember, this is just to give us an idea of what is happening with our reciprocal. So when you sketch in the sine function, do it in a dashed curve. Okay, not a solid curve. All right, I know that wherever I have a point on the midline, that's going to be my asymptote, because that was the zeros when we didn't have any transformations. And then the maximum points of my sine curve are going to be the vertices, so to speak, of the parabola, as are the mins. And then we draw close to that vertical asymptote, but we don't cross it because that's where the function's undefined. Nice job, guys. Okay, so for the domain, we say that it's from -infinity to +infinity. X, oh, goodness gracious, come back. Sorry, guys. Okay, x cannot equal. Our first asymptote that I see is pi over 2 plus half the period, so pi k. Where k is any integer, make sure that you define what k is, otherwise it doesn't really matter to us. So where k is any integer. Okay, the range goes from -infinity to -1 inclusive union. It jumps up then to 3 to +infinity. All right, rad. There's cosecant. Now, the other reciprocal that we're going to do in these notes is secant. This is the reciprocal of cosine. Okay, so we're going to go along and do very similar. We're going to sketch cosine. Okay, let me label our axes real quick. Goes up to 1, down to -1, pi, 2 pi, 3 pi, 4 pi. Okay, and we're going to sketch cosine. So at 0, cosine is 1, and then we go back to 0, down to -1, and so forth. And our midline is at the x-axis. Okay, and then we sketch in cosine. Now, similar to what we saw with cosecant, it's reciprocal. So the x's are going to be the same. We have 0, pi over 2, pi, 3 pi over 2, and 2 pi. At 0, we're going to have 1. At pi over 2 for secant, it becomes undefined. And then -1 and undefined, because again, wherever I cross the midline on our x-axis, because there hasn't been any vertical shifts, I'm going to have 0 over 1, which then becomes 1 over 0, which is undefined. So we're going to have vertical asymptotes at those locations. Wherever you see the maximum for the cosine curve or the minimum, those points still exist. That was 1 and -1, because the reciprocal of 1 is 1, the reciprocal of -1 is -1, and then we extend either up or down. Period stays the same as its reciprocal cosine, and amplitude doesn't exist for reasons we discussed already. Okay, so domain is going to be very similar to cosecant, -infinity to +infinity, but x cannot equal, the first asymptote that I see is pi over 2 plus half the period still, because it occurs if I go from 0 to 2 pi, I have 2 asymptotes in there. So half the period, where k is any integer, we have to define what k is. And I'm running out of room. Okay, range. We go from -infinity to -1 inclusive, union, inclusive 1 to infinity. Sweet. All right, so we're going to do, it's page 9 of your notes. We're going to transform secant so that you guys have that experience, okay? Here we do have a b value, so I'm just going to write y is equal to -1/2 secant 3 theta. Okay, so since a is being multiplied by a negative, we have a vertical reflection. The 1/2 means that we have a vertical compression. Okay, and the 3 being our b value means that we have a horizontal compression. Okay, so we're going to, like I said before with cosecant, you can transform those points. I'm going to go back to cosine, and I'm going to sketch cosine with these transformations so that I can then, wherever it intersects the midline, I know I'm going to have an asymptote, and then I have my max and minimum points of the curve. Okay, so 0, 1 for cosine pi over 2, 0, -1, 0, and 1. And again, this is for cosine. Okay, for the transformation chart, we have 1/3 x, and then we have -1/2 y. Okay, so if I plug in 0 for x, I get 0. If I plug in pi over 2, I get pi over 6. Pi becomes pi over 3. 3 pi over 2 becomes 3 pi over 6, or pi over 2, and then 2 pi becomes 2 pi over 3. For the y values, if you plug in 1, you get -1/2. 0 is 0. -1 is 1/2. 0 is 0. 1 is -1/2. Okay, so the period of secant is 2 pi. We're going to affect that by b just like we would with cosine. So this becomes 2 pi over 3. That's our period. There isn't an amplitude because there isn't a max or minimum value. Let's go ahead and label our axes. It looks like we just go up to 1/2 and -1/2. How do I know that? The a value and my transformation chart. Okay, our period is 2 pi over 3. If I were to cut that in half, I have 2 pi over 6, which is pi over 3. Cut that in half, you have pi over 6. Okay, so that's what they are increasing by, is pi over 6. Pi over 6, 2 pi over 6, 3 pi over 6, and so forth. Okay, so our midline is still at the x-axis because we don't have a vertical shift. We have a coordinate at 0, -1/2, pi over 6, 0, and the pattern continues. So I'm going to sketch in the cosine function with a dashed curve because I'm not graphing cosine with these transformations. I am using cosine with these transformations to help me graph its reciprocal. Wherever it intersects the midline is where we have an asymptote. So I have a vertical asymptote at pi over 6, pi over 2. And then my maximum points, I extend up, not crossing that vertical asymptote. We know we can't do that. That's where our function's undefined, but it does help guide our graph. Oh, gosh. Nice. All right, and then last but not least, our domain. So our domain is all real numbers, but it can't exist where the asymptotes are. So x cannot equal pi over 6 plus our period is 2 pi over 3. If we cut that in half, we get pi over 3k, where k is any integer because we have to define what k is. We can't just state it for fun. I mean, you can, but yeah, you need to define it. Okay, and then our range goes from -infinity to -1/2 inclusive because there is a coordinate there, union 1/2 inclusive to infinity. And there, ladies and gents, are cosecant and secant. Part 1, reciprocals. Part 2, cotangent. Be excited.